stage. Okay, an early thing that people do is called data quality profiling. Has anybody heard of this before, profiling? Yes, I hope so. Anyone else heard of profiling? Yeah? Okay, so data quality profiling. In an ideal world, we might be able to go and ask our business what level of data quality, what's your data quality rules that you want, but they'll probably look at you and go, or don't know. But if I was to show you some characteristics of the real data that we've got, would you be able to tell me whether that was right or wrong? And they go, oh yeah, of course I can do that. So we employ something called data quality profiling. Now you can either write, if you're dead clever, you can write some SQL code yourself, but why bother? Because there's dozens of software tools around that can do this. And data quality profiling, you take a chunk of data, it might be your customer database or your logistics database or whatever, and then you subject it to this profiling, and it goes through and it builds up a story, it builds up some characteristics about that type of data. And these are the kind of things, we could talk about these for hours, but I've just got a couple of examples. So it could tell you, for the columns, what's the count? We've got 1 million, we've got 1 million rows in the database. What's the unique count of each column? So if I've got customer ID, if I've got 1 million rows of customer, and one column number 1 is customer ID, how many values of customer ID should I have? 1 million. So if you see, when it says row count equals 1 million, unique ID, if it's anything other than 1 million, there's a problem. But when you look at gender, how many unique values of gender should there be in the 1 million records? 2, 3, California 9. If you see 62, you've got a problem. Okay? So this is the kind of thing. You can have counts of nulls, blanks, patterns as well. So the pattern for a date, you might see stuff that is DD dash MMMMM, which is the full text, dash YYYY. And that pattern is 500,000 of them. But then there's DD slash MM slash YY, and there's 200,000 of them. And then there's somebody's put it in American format. So there's MM dash DD dash YY, and there's 75 of them. So you can see patterns. That's what patterns means. And with things like account numbers, N, 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 N for numeric, N, 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 alpha, 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 N. And you can see how many patterns there are for all these different, for every single column. You can have completeness. I'll come to this. You can have the primary key candidates. Anything that is close to unique doesn't have to be the primary key, because the profiling will look through and say, did you know that column has got a sort of 99.1% uniqueness? So that's possibly an alternative key. Is anybody a data type, the defined versus the actual? Anybody here a database administrator or ever been a database administrator? Yeah? Have you got any friends as well? Because normally they kind of sit in a corner on their own and nobody talks to them. So you can look, you could actually look in the database and you could see what the metadata type is. You could have this thing that was defined as integer 10, but it's actually got alphabetic characters in it. Okay? And that's because when the data was loaded, you turn off all the integrity, the data gets loaded, you turn it back on. So just because you've said it's integer now, it doesn't auto-magically go and change it. So the data type that's defined versus the data type of actually what's really in there can be it. You can have counts and percentage of each distinct value. So this is where you get to find out that there's a large number of these ones that say 1st of January 1900, or there's a large number where account name equals test. Why have we got, in our live database, why have we got 75 accounts called test? Okay, so it's actually as well as giving you the column counts, it can now give you percentage, etc. You can do things like referential integrity tests. This column over here in this table and this column here, they've got the same value. Okay, so you can do that. This is awesome, duplicate analysis. So the example, where I was talking about customers and rows. So here's Mr. Christopher Michael Bradley. Here's my postcode, and here's a Mr. C. M. Bradley, and here's a Chris M. Bradley. I periodically get mail. I very much doubt whether she's listening to the Periscope thing. I very often get some mail for a lady called Cynthia Mary Bradley. So it's C. M. Bradley. And what you would do with this sort of duplicate analysis is you let the software, have a look at this, and you say which are the most important fields. It's going to be the name, the family name, the middle name, the first name, date of birth, postcode, maybe a couple of others. And it comes up with a scoring, and it's like a probability score of whether this is a duplicate or not. And you can effectively move a slidometer of accuracy or a slidometer of duplication. If you wanted 100%, then everything has to be exactly the same before it flags a duplicate. If you bring it down a bit, it'll go, C.M. Bradley at this postcode, at this date of birth, really is the same as Mr. Christopher M. Bradley. Okay? So you get that? Entropy. So does everybody know what he's talking about? Because you're using a fancy word. So you do chemistry at school? Entropy. So what's entropy? State of disorder. Yeah. So you can actually do a count of the state of disorder. Yeah. Yeah. Yes, a lot of them will actually do that. So you can then sort of alter the slidometer. That'll do. So here's a couple. Here's things from a software tool. Has anybody used software for data quality at all? What have you got? Oh, there's George. Sorry. Which ones do you use? Ultrix, okay. Ultrix, I don't know, to be honest with you. So I was just getting confused. IDQ is, yeah. So this is one, I've got a copy of this. Yeah, I've got several here. This is Experian. So in this particular Experian Pandora, which is really good. So in this little example, we've got the name of the columns, what's the uniqueness, what's the completeness, how many nulls, how many formats, minimum value, maximum value, most common value. So straight away, we can do stuff like that. You can create, I skipped over one because it was without being able to drill into it, you can't see. This is quite good. You can build your own little dashboard. So in this case, rather than just saying how many are complete and how many are nulls, we build some rules and we create a dashboard. And so we've got seven rules there, and one of them is, is the email syntax correct? Is the first order a valid date, etc.? Is the UK postcode in a valid format? Surname is not null. It's been equally weighted. So you could create this dashboard to say, my valid or my accurate records are the ones that pass those 7 tests. And oh my goodness, we've only got, whatever that is, 68%, have passed the complete test. So it's kind of like balanced scorecard, that kind of thing. You can look at how things are trending, how things are trending over time. It's increased, the number of duplicates, decreased, etc. And then you can even look at things like, have I got sales header records without sales details records? That's probably okay. But if I had a sales detail record without a header record, that's really bad. Okay, so yeah, so it can do all that kind of stuff as well. Right. Zoom, zoom, zoom. Oh, yes. And when we come to do the data, when we come to do any data correction, you remember my little that little zigzag chart I showed you. There's 3 philosophies for correcting the data. And what we want to do is we want to have as little of this and as much of this as we can have. So automated correction, you can read the words on here, but I'll just tell you briefly. So automated correction is where we've got gender of 1, gender equals 1, and we replace that with gender code equals M. And gender code of 2, we replace that with F. And anything else, we replace that with U, unknown, undeclared. Okay? So there's a completely automated correction, because in our system, it's only M or F or U. So whatever came in, we know some of the values that have come in, so we've had automated correction. Yeah. You can get automated correction much more sophisticated, obviously, with addresses. You've probably seen these address lookup things, where you can validate against a postal code and you can get a fully detailed address. So that's automated correction. Yeah.
Which one is easier, to have rules inside the source system or in the transformation?
Okay, so did you all get the question? Can I repeat the question? Is it easier to put rules in the source system or in the transformation? The ideal is to have stuff at source. That's your gold standard, is to have things in source. But very often you've got old, inconsistent, sometimes kind of legacy systems, and you're trying to put them into an aggregated thing like a data warehouse or risk data aggregation or some reporting thing. So then you have to transform them. So ideally source, and then everybody's happy. And again, source using master data as well. Manually directed is where you can go up to a point. So it kind of does cleansing, it does correction up to a certain point, but then it has to have human intervention to say, yes, is that okay, or no. Okay? And then manual, pretty obviously, manual is where you have subject matter experts, data stewards, and they have to make the decision. So what we're trying to do is we're trying to get something that's a bit like this. So if this is our number of errors, and the number of errors could be very, very large. You could have thousands, tens of thousands of errors, and this, the y-axis is the complexity of the problem, or or the cost to fix it. We want to get something. Is it doing? That's interesting, because it's building on my screen here, but it's not building there. So let's try that again. Yes, we want to. Pardon? It's frozen. Oh, I could tell you, it's dropped the Wi-Fi. So what we're trying to do is we're trying to have as much, in terms of the numbers. We're trying to have as many as possible in this area, fully automated correction. Yeah, and we'll have a quick look at some of these things, substitution, etc. We're trying to have a small number in here and the smallest number here, because those are the most complex but the most costly as well. Dying on us. I'll turn this off in case this was interfering, but there's. I'll carry on anyway. So can you think of any industries where manual intervention manual correction might actually be needed more than you would normally think. Medical, exactly, in medical. So you don't want to have lots of stuff, automate, other than simple, you don't want to have lots and lots of stuff being, automatically corrected when it's got potential to harm, harm human life. I saw in one of the big pharmaceutical companies that I worked in, they had molecules which are called stereochemistry, left hand and right hand, stereoisomers. And whilst chemically they're the same, the way in which they bond with human protein is different. And one of them can kill you or cause harm, and one can be, very good, give you good therapeutic benefits. So you don't want some computer just going, doing automatic correction. You want to have somebody look at that. Okay. Right, good. So that's where we are. So data cleansing. It's going hideously slowly. I've used some of these terms down here, but just to give a couple of simple examples. Are you familiar with this sentence, by the way? Have you seen this one? Yeah? What's... Yeah, when it's the right one, it'll have all the letters of the alphabet. Yeah, absolutely right. So when you're practicing typing, on the English keyboard, the QWERTY keyboard, it's got every letter in the alphabet. So a lot of people get familiar with this. But we got a problem with it initially. There's some problem. So just to try and make it simple, let's have a look at how you standardize. So if we standardize, that's it. We've just changed the fonts, the colors. There's standardization. Next up, we have substitution. Okay, so with substitution, there's a few things where the spelling is wrong or the punctuation is wrong. So we substituted the correct values. Then after that, we've got deduplication. So pretty obviously, we want to get rid of invalid duplicates. That was, one of these is valid, So we're getting rid of invalid duplicates. Okay, and then lastly, with data quality, you have a thing called enrichment. You're bringing in additional data. You go out to and you buy other data sources. So enrichment. Okay, so there, we've added in. We've gone out and we've bought some extra data. Okay, so now that's the sentence that you're familiar with. So, ladies and gentlemen, if you actually try this, type this in: the quick brown fox jumps over the lazy dog. It has every letter in the alphabet. Kind of cool. So I used to get people to practice doing that. Okay. I am now going to jump to a couple of other things. When we look at, I mentioned data quality. I mentioned there's lots of different tools, and these are some of the components in data quality software. Who's got a? Did I ask that earlier? Who's got any data quality software right now? I asked, and did nobody put their hand up before? Okay. So these are lots of the components that you will see within data quality software. But like everything in life, you might have some which are just got this amount of capability and some that have got this amount of capability. So you have to decide how much effort, how much time, how much money you want to spend. It's a good job there's no vendor here from a data quality tool, because they'd tell you theirs was the best, no doubt. What I've done here is I've listed some of the major functional capabilities. I'll just let this build. So broadly speaking, you've got a data quality repository, so you can have the results of data quality profiles and scans. You can have rules put into that. So if you're constantly using a rule about names or account numbers or addresses, you can build that rule and then use it countless times in different data quality exercises. Monitoring, so you can trigger the rules, you can trigger replacements, that kind of stuff. Reporting, so you can do dashboards, exception reports, email alerts, SMS alerts, etc. The modern generation of the tools give you the ability to put somebody else's business intelligence or data visualization on top of the data quality tool. So you've got the powerful graphics and data visualization from someone else, but you've got the data quality engine doing all those good data quality things. It's kind of, I don't know, since I'm a car person, it's like taking this really awesome engine and putting it in somebody else's chassis. Yeah, okay. Tracking, so things like workflow, allocation of responsibilities. Here's this data quality problem. You've been allocated it. How do we track the resolution of that? What's happened next month, next year? What's happened to that type of data over time? Okay, so it's not just the tracking of the quality indicator, but the tracking of the resolution of the issue. So that's kind of like workflow. And then profiling. I showed you some examples of profiling earlier, and you can buy tools that will just do profiling, and you can buy tools that will do everything. You can even get free versions and trial versions of the data quality profiling software, and that's my little gift to you here. Is a list of a bunch of bits of software, and the ones that are highlighted in dark blue are ones that I know of that have got trial or limited edition or kind of free versions. Because I'm being recorded, I won't tell you what happened to a couple of my clients, but some people who had got big enterprise deals with large vendors, okay, such as this kind of vendor, let's say, for example, they went and got one of the free profiling tools to use that, even though they had, these massive global deals with a big vendor. So a lot of these data profiling tools are really, really good. They don't do the fixing. You've got to spend the big money to do the fixing stuff. But for the profiling and getting under the covers of finding out what the problems are with your data, you can do that. And believe me, things like this one, and all those ones that are in dark blue, they're pretty good. So go and have a look. And just to be fair, what I showed those screenshots, it was Experian Pandora was what I showed the screenshots of, and since they gave me a trial version about 2 years ago, I thought I may as well kind of use that then.